covariant curvature tensor or HIJK. So we define covariant curvature tensor with the help of Christoffel curvature tensor of second kind. Okay, so we define this RHIJK means covariant curvature tensor is equal to GHA or AIJK. Okay, now by using the definition of RAIJK, so we get means our aim is to explain expression for RHIJK. Okay, so expression of RHIJK. So we have RHIJK is equal to GHA or AIJK. Now, by using the definition of RAIJK, so this equal to GHA, this is del xj, Christoffel symbol AIK minus del xk AIJ plus Christoffel symbol AJB BIK minus AKB BIJ. This is the definition of Riemann-Christoffel curvature tensor of second kind RAIJK. Now we introduce this GHA in all the terms, means this is partial differentiation. Okay, so this is del xj del xj. If we introduce here GHA AIK, so minus AIK del xj GHA. Similarly, in the second term, minus del xk GHA AIJ, so minus AIJ del xk GHA. Okay, and then plus this term, so only simple multiplication, so plus GHA AJB BIK minus GHA AKB BIJ. Okay, so this is equal to, this is by definition A contract, so this is the Christoffel symbol of first kind. Okay, so del xj, the Christoffel symbol of first kind HIK, and then similarly for this term minus del xk A contract, Christoffel symbol of first kind H I J. Okay, and remaining terms minus Christoffel symbol of second kind gamma A I K del Ax J G H A minus minus plus gamma A I J del Ax K G H A and plus. Again, by definition, he contract Christoffel symbol of first kind HJB. So first we write B I K Christoffel symbol HJB minus B I J E contract HKB. Christoffel symbol of first kind HKB. Okay, so this is the next term. Similarly, now we shall use the formula of Christoffel symbols of first kind. What is the value of Christoffel symbol of first kind? So we have, since Christoffel symbol of first kind IJK, this is equal to 1 by 2 del Gij upon del Axk plus del Gik upon del Axj minus del G, this is in pair, Jk upon del Xi. Also, this is metric tensor. So Gij is symmetric. So we can use Gij is equal to Gji or Gik is equal to Gki as we suitable. Okay, so this is the definition of Christoffel symbols of first kind. And similarly, by using the property del Gij upon del Xk, this is equal to Ijk plus Jki. Okay, so we shall use these two properties, means first definition of Christoffel symbols of first kind and second is property of del Gij, means partial differentiation of metric tensor. Gij is equal to this thing. So by using the definition in this step, so this is equal to 1 by 2 here del y by del xj is as it is. This is del Ghi upon del xk plus del Gh plus del Gh upon del xi minus del Gik upon del xh minus 1 by 2 del xk del Ghi upon del xj plus del Gh upon del xi minus del Gij upon del xh. So this is this term. Okay, minus gamma Aik, Christoffel symbol of second kind Aik del xj Gha plus gamma Aij del xk Gha plus gamma Bik Hjb minus Bij Hjkb. Okay, so by taking common 1 by 2, so 1 by 2 common, and we differentiate partially with respect to del xj. So here this is del 2 ghi upon del xj del xk plus del 2 ghk upon del xi del xj minus del 2 gik upon del xj del xh minus del 2 ghi upon del xk del xj minus del 2 ghj upon del xk del xi and minus minus plus del 2 gij upon del xk del xh. Okay, and the next term is here minus gamma ai k minus gamma ai k. We will use the definition of this is haj plus ahj plus gamma aij here hak plus akh and remaining terms plus gamma bik hjb minus bij kb. Okay, so now here since partial differentiation is commutative, so this cancel, this is plus and this is minus, so this is cancel. And similarly here a and b are dummy indices, a and b are dummy index, so this is aik haj and here hjb. Also this is symmetric in two indices j and b, so we can write either this is b, so this is b and here b, so this is cancel, and here aij, so we can write here b, so a and here a, so this should be cancel. Okay, now remaining terms are this is equal to 1 by 2 del 2 ghk upon del xi del xj, this term, and plus del 2 gij del 2 gij upon del xk del xh minus del 2 gjj upon del xk del xi minus del 2 gik upon del xh del xj. So this is this thing, and remaining terms here minus or plus, first we write here aij akh this term, and this is minus bik BIK, this is BIK BHJ, BHJ. We can write also ASJ, so AIK, no problem, because B is dummy or A is dummy. Okay, so this is RHIJK, RHIJK is equal to, this is the definition, means the expression of RHIJK, so del 2 GHK upon del XI del XJ plus del 2 GIJ upon del XK del XH minus del 2 GHJ upon del XK del XI minus del 2 GIK upon del XH del XJ. Here this is plus. Again, by using the definition of Christoffel symbols of second kind, so we can write in terms of second kind or in terms of first kind. Okay, so this is AIJ, so this is AKH, this is Christoffel symbol of first kind, so plus GAB comma AIJ BKH, and similarly for here GAB GB, this is BIK or AIK BIK, and here BIK, so ASJ, because A and B are dummy, so AHJ. Okay, so this is GAB BIK ESJ. Since A and B are dummy indices, so no problem, we can write also GAB is symmetric. So this is the expression for RHIJK, means expression for covariant curvature tensor. Properties of covariant curvature tensor RHIJK. So first property is RHIJK is equal to minus RIHJK, means this is skew symmetric in first two indices. Okay, and similarly second property is RHIJK is equal to minus RHIKJ, means skew symmetric in last two indices. Okay, and similarly third property RHIJK is equal to RJKHI, means if we interchange pair of indices, means these, so no change the value of covariant curvature tensor. Okay, and last property, fourth property is RHIJK plus RH. This is we change cyclically, means IJK. So in place of I, J, J, K and K is I, means J, K, I plus R, again H, in place of J is K, I and J. So this is equal to 0. Okay, it means if we change cyclically last three indices means h, I, j, k. So this is 3. So if we change I, j and k, okay, so this is I, j, k, j, k, I, k, I, j. So this should be 0. So these four properties are very important properties. So proof is very easy. Only we will use the definition of RHIJK. Okay, so proof is very easy. I am going to prove first one. So first proof is proof we have by the definition of RHIJK. So this is equal to 1 by 2 del 2 gij on del xh del xk plus del 2 GHK upon del XI del XJ minus del 2 GIK upon del XH del XJ minus del 2 GHJ upon del XI del XK and last term plus GAB AIJ comma BHK minus GAB comma AIK BHG. Okay, so now interchanging first property is HI IH means if we interchange H and I. So interchanging H and I. Okay, so this is equal to R I H J K means in place of H I and in place of I is H. So del 2 G H J upon del XI del XK plus del 2 GIK upon del XH del XJ minus del 2 GHK upon del XI del XJ minus del 2 GIJ upon del XH del XK plus GAB AHJ BIK minus GAB AHK BIJ. Okay, so this is very easy to see. If we take common minus sign, so we get RHIJK. Okay, means this is equal to minus 1 by 2. If we take minus sign common, so this is del 2, this is first term Gij upon del XH del XK plus del 2 GHK upon del XI del XJ minus del 2 GIK upon del XH del XJ minus del 2 GHJ upon del XI del XK and then plus GAB comma aij bhk minus gab aik bhj. Okay, and this is rhijk with negative sign. It means this is very easy to see that rk equal to minus rihjk. Similarly, we can prove ghijk is equal to rhijk is equal to minus rhikj. Okay, so this is very easy to prove. Now, proof of second means rhijk is equal to minus rhikj. It means this is skew symmetric in last two indices. Okay, so proof is very easy. We have the definition of rhijk means rhijk is equal to 1 by 2 del 2 gij upon del xh del xk plus del 2 ghk upon del xi del xj minus del 2 gik upon del xh del xj minus del 2 ghj upon del xi del xk plus gab Christoffel symbol aij bhk minus gab Christoffel symbol aik bhj. Okay, so now interchanging j and k. Now interchanging j and k. We get r h ikj is equal to, so in this expression we will interchange j and k. Okay, so this is equal to 1 by 2 del 2 g I in place of j is k on del x h del xj plus del 2 g h j upon del xi del xk minus del 2 g I j upon del x h del xk minus del 2 g h k upon del xi del xj. Okay, plus gab gamma aik bj bh. In place of k is a j, so hj or jh, no problem because this is symmetric, minus gab gamma aij gamma bhk. Okay, so you see here, this is, if we take common minus sign, so we take minus common, so minus 1 by 2, so by taking minus sign this will be here, so del 2 gij upon del xh del xk and this plus del 2 ghk upon del x I del x j and minus del 2 g I k upon del x h del x j minus del 2 g h j upon del x I del x k, and this is plus g a b gamma a I j gamma b h k minus this g a b gamma a I k gamma b h j. So by definition, this is R H I J K. So this is minus R H I J K. So indifference proved the second property. Proof of third property means cyclic property. This is cyclic in last three indices. Okay, so proof is very easy. So we have R H I J K. This is equal to 1 by 2 del 2 g I j upon del x h del x k plus del 2 g h k upon del x I del x j minus del 2 g I k upon del x j del x h minus del 2 g j k jh upon del x I del x k, these terms, and then plus g a b gamma a I j gamma b k h minus g a b gamma a I k gamma b h j. Okay, now our aim is to find R H J K I. So now this is 1. Changing cyclically. Okay, means I is equal to j is equal to k, and k is equal to I. Okay, so interchanging I j k cyclically. Okay, so we get R H J K I. So this is equal to 1 by 2 H as it is. So del 2 G J K upon del X H del X I plus del 2 G H I upon del x j del x k minus del 2 g I del x k del x h minus del 2 g j means k h as it is upon del x j del x I, and here plus GAB gamma A J K gamma B I H minus GAB gamma A J I gamma B H K. So this is secant, and similarly again changing cyclically. Again changing cyclically. I, J and K. So we get this is R, H, J is K, K is I, J. So this is equal to 1 by 2 del 2 G K I upon del X H del X J plus del 2 G H J upon del X K del X I minus del 2 G K J upon del X K I del X H minus del 2 G I H upon del X J is K and I is J plus. So this is GAB, Christoffel symbol A K I comma BJH minus GAB A K I J BHI. So this is third. By adding 1, 2 and 3. Okay. So by adding 1, 2 and 3, so we get, so here this is very easy to see that all the values means this is first, okay, this is first, here this is second and this is third. So you see this is very easy to prove, means 1 2, there are 1 2 3 4 12 terms are second order partial derivative. Okay, so here 6 are positive and 6 are negative. Okay, so this is cancelled, all the terms are cancelled and remaining terms also cancelled, because there are 6 terms, 3 are minus and 3 are plus. So this should be 0. By adding we get here, we get R H I J K plus R H J K I plus R H K I J is equal to 0. Okay, and hence proved. Bianchi identity. This is very important. Bianchi identity. This can be written in two ways. First is curvature tensor of second kind, and in terms of curvature tensor of first kind. Okay, so how we prove? So proof is very easy. By definition of curvature tensor, so proof is very easy. So we have, by the definition, R A I J K is equal to del X J A I K comma A I K minus del X K gamma A I J plus Christoffel symbol A, we replace K by dummy index, so A B J B gamma B and J B, so I K. Okay, so this is the definition. Now introducing geodesic coordinate with the pole at P0. Now introducing geodesic coordinates with the pole at P0, then we have at P0 Christoffel symbols of first kind as well as second kind vanish. Okay, it means Christoffel symbols I, j, k is equal to 0 and Christoffel symbols I, j, k is equal to 0 at the pole. Okay, this is Christoffel symbols of first kind and this is second kind. So at pole, covariant derivative reduces to partial derivative, okay, to ordinary partial derivative. So now this is 1. Now differentiating covariant, okay, of 1. So now differentiating covariantly with respect to here a, I, j, k, so L, okay, with respect to x, L. Now differentiating covariantly with respect to x, L and imposing the condition of geodesic coordinates, okay, and imposing the condition of geodesic coordinates with the pole at P0, we get R A I j k L is equal to, this is del 2 gamma A I k upon del x L del x j minus del 2 gamma A I j upon del x L del x k. This is at P0. Similarly, R A I k L j means by changing cyclically, okay, by changing cyclically j, k and L. So this is equal to del 2 A I L upon del x j del x k minus del 2 A I k upon del x j del x k at P0 and R A, this is I L J K, means again changing cyclically K, L and J. So we get del 2 Christoffel symbol A I J upon del x K del x L minus del 2 gamma A I L upon del x K del x J at P0. Okay, so by adding above three values means are a, I, j, k, l. This is and this plus this. Okay, so by adding above relations, so we get R A I J K L plus R A I K L J plus R A I L to prove of the second form means in the covariant curvature tensor form, Bianchi identity we multiply by GHA. Okay, GHA, this is metric tensor. So we get GHA R A I J K L. Okay, so this is covariant differentiation with respect to XL. Also we have by Ricci lemma covariant differentiation of metric tensor is 0. It means metric tensor is covariant constant. So we can write this thing GHA R A I J K. This is covariant differentiation with respect to L, and this is equal to A contract. So R H I J K comma L. So similarly we will write another 2 and then by adding we get. Okay, so similarly we can write another 2 values and then by adding we obtain R H I J K L plus R H I K L J plus R H I L J K equal to 0. This is covariant differentiation. Okay, comma represent covariant differentiation and is proved.